Hello everyone. Hope you are safe and sound. Let us start a new chapter. We will learn chapter 3 metals and non-metals. We have already learned about different types of elements in standard 9. We have seen that elements can be classified as metals or non-metals on the basis of their properties. You may think that how to differentiate metals and non-metals. So the easiest way to differentiate them is by comparing their physical properties. Now, these properties of metals and non-metals you have already studied in standard 8, but let us revise it again. First of all, let us see the examples of metals: iron, copper, aluminium, magnesium, sodium, lead, zinc. These all are the examples of metals. There are other examples of metals also, but from these examples, what can we infer? We can see that in all these examples of metals that they have a shiny surface, which means we can say that they have luster. Luster means shine. So that we can say that the first physical property of metal is that the metals have shiny surface, which means we will say that it has metallic luster. Second physical property of metals is that they are hard. You can see in all the examples that the metals are generally hard. The hardness varies from metal to metal. It is not like that all the metals will have same hardness. It will differ from one metal to another. Okay? So till now we learned two physical properties of metals. One, that they have luster, metallic luster, which means they are shiny. Second property we learned that they are hard and their hardness vary from metal to metal. Let us learn next physical property of metals. Some of the metals can be beaten into thin sheets, and this property is called malleability. Okay, so this is the name of the property. What it is? Malleability. What is malleability? The property of a metal to be beaten into thin sheets is called malleability. We already know that gold and silver are most malleable metals. Why? Because gold can be beaten into very thin sheets. Same way, silver also can be beaten into thin sheets. That is why gold and silver are the most malleable metals. Here we learned three properties. First, they have shiny surface, they are hard, and third one, they are malleable. Remember, the property is malleability, and the metals which possess this malleability are called malleable. So, gold and silver are malleable metals. Let us learn the next property, which is ductility. What is ductility? The ability of metals to be drawn into thin wires is called ductility. Do not be confused with malleability and ductility. Malleability is the property of metals to be beaten into thin sheets, whereas ductility is the property of metals to be drawn into thin wires. And the metals which possess malleability are called malleable. So, the metals which possess ductility will be called as ductile. Which metal is most ductile metal? Gold is the most ductile metal. You will be surprised to know that a wire about 2 kilometer length can be drawn from 1 gram of gold. Think of it. Only from 1 gram of gold, 2 kilometer length wire can be made. So, how much ductile the gold is? So, gold is considered as the most ductile metal. And it is because of metals' malleability and ductility it is possible to give different kind of shapes according to our needs, because metals are malleable. We can easily make thin sheets from it. Also, we can draw thin wires from it. So because of these two properties, malleability and ductility, we can give different shapes to these metals according to our needs. Now let us understand activity 3.5. We have to take an aluminum or copper wire and we have to clamp this wire on a stand as shown in the figure. These are aluminum wires. These are copper wires. So we have to make arrangement as shown in the figure. Fix a pin to the free end of the wire using wax. We have to attach a pin using wax where the end is free. One end of the wire is attached with the clamp, right? And another end which is free, there we have to fix a pin. Now what to do? We have to heat the wire with a spirit lamp, candle or a burner near the place where it is clamped. So the wire where it is clamped, that part we have to heat by, we can do it by a candle or a burner or a spirit lamp. After some time we have to note the observation. What will we observe? The above activity shows that the metals are good conductors of heat and have high melting points. What is the meaning of melting point? The temperature at which the solid starts melting, or else the temperature at which the solid changes its state to liquid. That is melting point. So when we'll give heat to this wire, we will observe that the metals are good conductors of heat and they have high melting point. Silver is the best conductor of heat. Same way, copper is also best conductor of heat. On the other hand, lead and mercury are comparatively poor conductors of heat. Now let us see another activity to find the next physical property of metals. We have to set up an electric circuit shown in the figure. We'll have battery, clips, switch and bulb. We have to place the metal to be tested in the circuit between terminals A and B as shown. You see, A and B are clips, right? So what we have to do? We have to insert the sample of metal in between these two clips. Okay, so whichever metal will take for experiment that need to be attached in between these terminals A and B. Now, if we switch on the circuit, what will happen? We will see that the wires that carry current in our homes have a coating of polyvinyl chloride. I'm sure you all have seen this type of wires which carry current in our homes. And this type of wires have a coating of polyvinyl chloride, PVC. You can see it is a rubber like material, right? So these wires are coated with this type of rubber like material. So remember that the wires have coating of PVC, polyvinyl chloride. Why are electric wires coated with such kind of substances? Wires are coated with such kind of substances because it gives resistance to fire. Also, it prevents from rusting. So, in between this A and B, if we keep metals, then it conducts electricity. So, we got the physical property that metals are good conductors of electricity. Also, we have learned that metals produce a ringing sound when strike to another metal, and that property is called sonority. Okay, so the metals are sonorous because they possess property of sonority, which means metals produce a ringing sound when striking on a hard surface. So this is all about physical properties of metals.